Thanks for joining again today. I know there's been a bit of a gap. I was traveling last week. I was actually at UC Davis, my undergraduate alma mater. Saw some folks I haven't seen in several years. Met some folks I know who attend these conversations here on YouTube, so that was fun. What I wanted to talk about today is, well, first of all, the fact that the weather has finally calmed down in California. This is a welcome reprieve for a lot of folks who really just had a rough winter for different reasons. It was an active winter, it was a stormy winter, it was a cold winter. Some folks dealt with flooding, extensive wind damage, or just winter conditions that were just doggedly persistent. So, a lot of folks, I think, are grateful for the now finally spring-like warmth and sunshine that are occurring. But the legacy of the winter is not over yet, because as of right now, there remains a record-breaking snowpack in the southern Sierra. And this is true both for the western slope watersheds in the southern Sierra and also the lee-side eastern slopes. So this remains a major concern moving forward for both the San Joaquin Valley, in particular the Tulare Lake Basin, but also the lee side, so the Owens Valley and some places a bit farther to the north, could start to have significant flooding in the coming days. And the big melt has begun. Temperatures are, of course, if you're in Northern California, warm enough for significant snowmelt to occur. The good news is no huge heat waves are on the horizon. It looks like it's going to cool down again shortly, although not as cool as it has been. It'll be more seasonable, temperatures that are closer to average for this time of year, which of course average temperatures by the time we get to mid-April are generally warm enough to cause significant snowmelt. So the peak has come and has now passed, but the peak is really, really big. We're still talking about, in a couple of smaller watershed, peaks of 300 to 400% of average snow water equivalent in the watersheds, for example, upstream of the Tulare Basin. So that's a pretty big deal. And all the flooding we're seeing right now is just a taste of what is likely to come, because these flows that are high right now are mainly high based on the melting that occurred a while back and precipitation that fell a long time ago. Most of the snow up there has yet to melt. In fact, somewhere around 98% of the snow that was up there at the peak is still there and is still going to melt, is still going to become runoff and fill rivers, reservoirs, and probably floodplains, hopefully not too many uncontrolled floodplains downstream. So the risk of flooding in the Tulare Basin and the rest of the southern San Joaquin Valley, as well as some of the east side flood vulnerable locations in the Owens Valley and going further north into western Nevada as well in some spots, are at significant risk of flooding in the coming weeks, and that flooding is likely to become more widespread than what we're currently seeing. I still don't see any immediate indications of major heat waves or late season atmospheric river events that would cause a rapid, sudden increase in snowmelt rates. So right now, those worst case snowmelt flood scenarios don't appear to be immediately on the table, although of course the potential will remain all the way through May or probably June. We may still be looking at significant flooding into the summer in some spots, depending on how things go. So this will continue to be a major story. I won't focus too much more on it right now because the situation is largely the same as it was last week when we discussed this, but certainly the risks have not decreased. We're still just waiting for the big snowmelt pulse to come when this flooding gets worse, which it almost certainly will. Wrapping up the winter, looking at some of the statistics for what happened this year, which I finally had time to do this week, it was a pretty remarkable winter in a lot of California. So precipitation-wise, there were parts of the state that experienced their wettest winter on record this year. There were also parts of the state that saw unremarkable precipitation this winter. And so the places that were really wet and saw conditions that were either the first or second wettest seasons on record in over 100 years of record keeping were mostly in central California. So actually this includes portions of the Central Valley, the central and southern Sierra foothills, and the high elevations in the Sierra, extending in a fairly narrow band even into parts of the Great Basin. This was, of course, the axis along which the most intense atmospheric rivers repeatedly made landfall this winter, and this is one of the main reasons, this record-breaking precipitation, why we have a record-breaking snowpack in the southern Sierra. It was the part of California that saw a record wet winter. But this record wet winter was also very cold, especially in recent historical terms. In fact, in California generally, this year was the coldest winter in 44 years. That is a long time for folks. For anyone who essentially wasn't in California before 1979, this was probably the coldest winter that you've experienced. And so that is a remarkable statistic. This was a genuinely cold winter. In fact, in a few places in Northern California, March in particular was the coldest March on record in over a century, which is in some ways even a more remarkable statistic because we don't hit all-time low monthly temperatures records very often anymore in our warming climate. But one piece of interesting information is that although this past winter was indeed the coldest in several decades in much of California, winters this cold used to be pretty common as recently as the 1950s and 1960s. Every few years, in fact, there was a winter as cold or nearly as cold as the one we just experienced. We go back to before 1960. And so that's really just a testament to how much things have warmed in the intervening decades. That winter that would have been relatively cool, but not that unusual by mid-20th century standards, feels astonishingly chilly by early 21st century standards in this part of the world. So interesting to reflect on just how much things have changed. And I think the consequence, of course, is that we actually got a cold winter and a wet winter that aligned. And so that's why the snowpack is so robust. That's why so many places at lower elevations actually ended up experiencing unusually low elevation accumulating snowfall this winter repeatedly because that combination of cold and wet we haven't seen in a while. Apologies, you can probably hear the neighbor's dog 2 doors down in the background. We'll see if he decides to run away after a couple of minutes. I think the challenge this year is that there was a lot of water concentrated in one part of the state and not so evenly distributed in other parts of the state. So the experience, your mileage may vary greatly, and this is, of course, why the maximum snowmelt flood risk potential is in the watersheds that drain primarily the southern Sierra, but also to a lesser extent the central Sierra. The northern Sierra has a large snowpack too, but it is not nearly so extremely anomalous, and the flood control systems in the Sacramento watershed are generally more robust than further south on the San Joaquin watershed. So there is less concern regarding spring snowmelt flood risk up north. It's likely to be manageable north of the Delta, perhaps less so south of the Delta. So this was a cold winter, although a cold winter only in a recent context, whereas in the early 20th century this would have been not that unusual. But certainly a very wet winter in central California. And this now brings us to a point where in the past decade, most parts of California have experienced their driest year on record. Some places have experienced their driest year on record twice, having experienced it in either 2013 or 2014, and then again in 17 or 18 potentially. And then also experienced, especially in northern and now also in central California, their wettest year on record. In 16, 17, that was true for most of northern California, and now this year, that's true throughout much of central California. And so now about 2/3 of California has experienced both the wettest and the driest years on record within the past decade, and in some cases repeatedly. I wonder what that sounds like. We've been talking about increasing precipitation whiplash, or maybe more broadly and more appropriately, increasing hydroclimate whiplash for a long time now. And this is what I like to call anecdata. It is, to be fair, not a complete sample size. It's not a comprehensive analysis, but it is definitely a recent observation of the lived experience of Californians that is very consistent with both theory about how things should evolve in a warming climate and also climate model projections in a warming climate. California still, to this day, has not experienced a large decrease or a large increase in its annual average precipitation, even in a decade when we've experienced both the wettest and the driest conditions on record across now increasingly wide swaths of the state. And so, again, this is consistent with the notion that we are going to see more variability in precipitation and in hydroclimate more generally, and that the risk of droughts, but also of severe floods, is rising in a warming climate, and that we can't let that relatively minimal trend in the average precipitation lull us into a false sense of security. We need to be co-managing the increasing risks of drought and flood. The other interesting thing that keeps coming up is folks are repeatedly asking, why was this winter so different from seasonal predictions? And I always like to remind folks that seasonal predictions are inherently probabilistic, and nobody was saying that this winter will definitely be dry, but there was a tilt in the odds, according to predictions, that there was a higher than average likelihood that this winter would have been drier than average for most of California. That, of course, did not happen. But the reason why it didn't happen is still not clear. And folks have speculated it could be due to the large volcanic eruption in Hungatonga, which was a very unusual volcanic eruption in that it was extremely powerful and injected a record-breaking amount of water vapor all the way up into the upper stratosphere, which we've really never observed before in the satellite era, so at least since the 1970s. That might be having a different effect than usual. There have also been some discussions, interestingly, about how changes in shipping regulations and in the amount of sulfate aerosols that are, I believe, emitted by ships burning bunker fuel. This year, new regulations went into effect that they actually had to burn cleaner fuels or scrub more of those pollutants from smokestacks before emitting them into the atmosphere. It's at least a distant possibility that there is some additional regional shifts in climate induced by changes in aerosol emitting patterns from shipping lanes. So these are, of course, things that don't get accounted for in seasonal predictions, but could very well have played at least a partial role in some of what we're seeing. So time will tell. There'll be analyses on these things, and I'm not saying that either of these definitely affected regional California climate in any particular way. I'm just sort of trying to illustrate the kinds of diverse factors that could potentially have been relevant, and why sometimes, despite your best efforts, seasonal predictions go awry. Sometimes things happen that are just truly unpredictable from the outset. And if we had a magic way of incorporating those factors into predictions, then maybe we would make better predictions. But honestly, it's hard to know some of these things in advance. So I don't know why this winter was as divergent from seasonal predictions as it was, but there are some unusual things that happened this year that might have played at least a partial role. It's also possible it was just a bad forecast and this was just due to bad luck. But it will be interesting to see if there are traceable physical reasons why this year's prediction wasn't better. Speaking of predictions and seasonal outlooks, we're now entering an interesting period in California and the eastern Pacific Ocean because it now appears that El Nino is rapidly accelerating. In fact, there are now very warm waters, as much as 10 degrees Fahrenheit above average off the coast, the tropical coast of western South America, near the coast of Peru. Where there has been some severe flooding, which is something that often happens in the desert when El Nino comes knocking. And this is a classic El Nino onset there. There's floods in the deserts. The tropical ocean is way warmer than usual as the normal cold water upwelling dies off. That's why temperatures in the ocean there can rise so dramatically near the coast. It's not that the surface ocean magically warmed by 10 degrees so much as it's that the very cold water coming up from beneath got essentially shut off, and so that warm water is able to remain near the surface more easily without being replaced by cold water from below. And now there is a westerly wind burst occurring, which will further inhibit that upwelling and expand the warm pool in the eastern tropical Pacific. So all signs point to go at this point for rapid development of El Nino, potentially by midsummer. And there are some indications in the dynamical predictive models that this El Nino could become quite strong by next fall. The European seasonal model right now is especially aggressive, predicting an El Nino comparable to the super El Niños of 82, 83, 96, 97, and 2016, 2017. It's too early, really, to talk about implications for California, and it's really still too early to talk too much about even the intensity of El Nino because we just don't know. We're on the wrong side of the spring predictability barrier. The European seasonal model might be way overdoing it still. So I do want to temper expectations somewhat, except to say that I do think it is now very likely we'll experience an El Nino event, and there's an unusually high chance that it will be stronger than a weak event, let's say. So there is a relatively high chance it becomes moderate or stronger by the autumn or winter to come. And if it does so, it would have significant implications for California's late summer, autumn, and winter conditions next year. I will again emphasize that our recent work on the rising risk of a California megaflood did suggest that the very highest likelihood of an extremely strong and extremely wet 30-day storm sequence that could produce widespread severe flooding in California would occur during strong, moderate to strong, East Pacific centered El Nino events. And that may be where we're headed this year. So it's just food for thought. It's really too early to make any specific predictions. We'll see how El Nino evolves, but it certainly looks like it's evolving, and the atmosphere is cooperating with the ocean and vice versa. They do appear to be coupling in a way favorable for continued El Nino development. And so we'll just have to see how that goes in the months to come, but I expect it to be a pretty significant story in the coming months. Hearing some more barking there. See if the neighbor dog obliges. All right. Well, the other interesting bit right now is that global ocean temperatures have reached a record high level in aggregate. No one alive today has ever experienced a global average ocean temperature as warm as it is right now as we sit here having this live office hour conversation. And that is remarkable partly because the ocean right now is so cold off the coast of California. It's way colder than average because of all of the enhanced upwelling and the storm activity we've seen recently. And so that is a huge outlier globally, where almost everywhere else on Earth the ocean right now is remarkably warm. And so it is, despite that fact, that we see a record warm global ocean right now. El Nino, the developing El Nino, is clearly contributing to this. But there's also anomalous warmth in the Arctic and even in the western portion of the North Pacific Ocean. So this is quite localized to the west coast, essentially, of North America. And as the seasons change, I expect that to change pretty rapidly. In fact, there is some indication that we may rapidly shift from below average ocean temperatures this month and probably still next month into May to above average ocean temperatures by later in June and into July. So there may be quite robust May and June gloom this year in coastal California, which is not that unusual, but it may quickly go away later this summer, and we may start to see more humid heat waves potentially later this summer as the ocean temperatures warm, as we get coastally trapped Kelvin waves coming up the coast and inhibiting upwelling potentially as an indirect result of this developing El Nino event. So we'll talk more about that later, but I did just want to update everybody that El Nino does appear to be on track. The odds are even higher than they were a few weeks ago when I spoke about it last. So yes, that's probably still in the cards. All right, well, that's pretty much all I've got for the monologue portion today. I'm going to start looking at the comments in just a minute here. But let's see. I might be able to get through most of these today because the comments so far are not too lengthy. So, hey, maybe I can get to everyone. Question from Bill about the eruption. There was a volcano in Kamchatka Peninsula in Russia that just erupted within the past 24 hours. It was quite a significant eruption. It was a stratovolcano, which are known for particularly explosive eruptions. So not the nice, relatively gentle, effusive lava eruptions that you sometimes see in Hawaii or in Iceland, but quite violent explosions with large eruptive columns, dangerous pyroclastic flows, and stuff like that. It does appear that this eruption was tall enough to inject some material into the stratosphere, both ash and sulfur aerosols. I don't know how much yet. It's a little bit speculative. There's some initial estimates that it is a relatively modest injection and that the plume height didn't get that high into the stratosphere, so My guess is this is unlikely to have a large effect on global climate, at least compared to other recent eruptions like Hungatonga. But we will see. There could always be another larger eruption, or we may have underestimated the effect. So, be interesting to follow in the coming days. As of right now, I don't expect this to have a large influence on climate, but volcanoes do affect the climate. So, but it is largely a question of how effective a particular eruption is at injecting large amounts of either ash and/or sulfate aerosols high into the atmosphere beyond the troposphere, where they will, essentially fall out within days, all the way into the stratosphere, where they can persist for months or even years in some cases. So there is a question of just how robust that eruption was. I don't know yet, but I don't think right now it's likely to have a large effect on climate. There's a question from Amethyst. How many atmospheric rivers hit California this water year? The news coverage has varying numbers, and I haven't seen a complete number for the time frame. Yeah, I think this all comes down to a graphic that was put out by Scripps Institute, the Center for Climate and Weather Extremes down there at UC San Diego Scripps. That the graphic summary says that there were 31 atmospheric rivers this winter, but it doesn't say over what region. And the map depicts the entire west coast of North America. So I think a bunch of newspapers and television programs have gone with the, I believe, incorrect headline that 31 atmospheric rivers made landfall in California this winter. I do not think that's correct. I think the number is closer to 16 or 17, which is still a large and above average number, but it is about half of the total number. The other half, of course, are made landfall elsewhere along the west coast, Washington or Oregon or British Columbia. So I don't think that the 31 number is correct, even though it's being reported everywhere. I'm not sure folks necessarily read that diagram closely. One thing that was interesting from this that I gleaned is that none of the atmospheric rivers that made landfall directly in California were considered extreme or exceptional atmospheric river events. There were multiple ones that were moderate to strong, but none were extreme to exceptional. And we did see significant flooding and significant wind damage. And so I think this tells us two things. One is that it could have been worse, and this is something I've been saying for a long time. But the other thing it tells us is that the atmospheric river scale isn't perfect. It's not measuring everything. It doesn't scale directly with storm-related impacts in terms of precipitation or wind damage, because those things are just as much related to the strength of the parent low-pressure system as they are to the strength of the atmospheric river. And although there's a correlation between those two things, it's not perfect. You can have a moderate atmospheric river that has outsized impacts from a wind damage perspective if you have a very strong pressure gradient, for example. Or you can have a relatively modest atmospheric river or a very strong atmospheric river that doesn't produce serious flood impacts because perhaps the upward vertical motion in the atmosphere is lacking. Perhaps there's not enough dynamical forcing to squeeze out all of that moisture. Even though there's a lot of moisture in the atmosphere moving violently above your head, if there isn't enough upward motion to squeeze it out as precipitation, then you aren't going to get a severe rainfall event even from an extreme atmospheric river. So there is some variance there. I still do think it's very helpful to have this atmospheric river CAT scale because it does help objectively quantify these events in some meaningful way. But it also doesn't tell us everything, and it is, I think, somewhat subject to misinterpretation. Because just because something is an atmospheric river does not mean it's a high impact storm, and just because something is not an atmospheric river doesn't necessarily mean it's not a high impact storm as well. So that goes both ways, I think, but it's a good question. Polymana opines that since being born in 1999, this is the coldest California winter that I've ever experienced. The numbers bear that out. This would indeed be the coldest winter since 1979. So 1999 is definitely in that window. Is there any risk of snowmelt or spring flooding in the Los Angeles area? From Haley. The answer is essentially no. I don't know how much snow is left in the San Bernardinos or elsewhere. But in general, no. There is not. There might be some minor risk locally in places where there's actively still a lot of snow on the ground, but there isn't the same kind of huge snowpack reservoir that there is in the Southern Sierra. So for perspective, in the Southern Sierra right now, the snowpack upstream of certain reservoirs is enough to fill those reservoirs multiple times over. That's a big deal. In Southern California, I just don't think that there's that much cumulative snow, because even though it was quite deep in some places, the amount of land at that elevation is much less in Southern California. So the total snow water volume in terms of our incredibly awkward but still used measure of millions of acre feet being the volumetric measure. By the way, an acre foot is the quantity of water it would take to flood, inundate an acre of flat land 1 foot deep. So it is a volumetric measure of a very archaic nature. We just don't have the same volume of water stored up there in the Southern California mountains. So as disruptive as this winter's blizzards were, there's not a whole lot of concern about new flooding in Southern California. So right now, the main risks are the San Joaquin Valley, in particular the Tulare Lake Basin, and then also, to a somewhat lesser extent, the eastern slopes, the Owens Valley. The caveat is that LA does get a lot of its water from the LA aqueduct, which originates in the Owens Valley, and there's already been damage to that aqueduct at least once due to flooding this year. That could happen again, and so even though the LA metro itself is very unlikely to experience flooding from snowmelt or really anything else the rest of the season, it is possible that upstream flooding in the Owens Valley near the LA aqueduct could nonetheless have knock-on effects for Southern California's water supply. So that is a significant consideration, and so we'll just have to see how that flood risk unfolds in the Owens Valley on the lee side slopes in the coming weeks as well. All right, let's see here. Question from Puma Mountain Lion 777. Will global warming raise the troposphere enough to where the cloud layer can overcome the topographical barrier in the Sierra Nevada mountain range and reach Nevada, causing precipitation increase? Another interesting dynamical question. We do have a little bit of research that suggests that at least during the most extreme storm events, the answer is somewhat yes. It's essentially possible that the orographic sharpness, essentially, of precipitation during extreme atmospheric river events may become less sharp. So in other words, the ratio between how much water that falls on the western slopes versus the eastern slopes may decrease, and the eastern slopes may become slightly wetter at a faster rate than the western slopes in a warming climate, which would be kind of interesting. And it does have something to do with the complex relationship between the hydrometeor fall rate from clouds of different depths and different temperature profiles. So it's fairly complicated, but there is at least a little bit of evidence that the answer is maybe yes to this question, and that in a warmer climate, both the coast ranges and the Sierra, and this is probably true farther north as well, up in the Cascades, will be a less impenetrable barrier because more and more of the moisture will make it over the top of the mountain range, essentially. It doesn't mean that precipitation is going to decrease on the windward side because there's more moisture overall. It's just that a greater fraction of it is potentially going to make it over the crest with the potential to fall on the lee side. So maybe that's something that might actually happen, at least to a small extent. Gonna keep going down here. A question from Jack Lee about the cold ocean surface temperatures off of the coast of California, how long that might last and what the implications are. I think I covered that a little bit earlier, but just to re-emphasize, I think it's probably going to stick around certainly for this month and maybe into next month, so probably April, May, before potentially rapidly disappearing at some point this summer, maybe in June or July, as we start getting the more robust influence of El Nino indirectly through these coastally trapped Kelvin waves, which can inhibit upwelling. And the upwelling, of course, is always why California's water temperatures are cold. If they are cold, it's usually because we have enhanced upwelling of cold water from beneath. So I think that by mid to late summer, this might dramatically reverse itself. We might go from well below average near surface ocean temperatures to well above average at some point in that period. It does mean we're probably going to have a robust marine layer and fog layer for a good portion of May, maybe into early June. We're already starting to see kind of a spring-like marine layer in some places right now, so that's not too surprising. And then later this summer, I might expect the opposite to occur. It might be that the marine layer gets suppressed a bit earlier than usual later in the summer, as if those temperatures do warm, that might increase the nighttime humidity, especially the mugginess in Southern California overnight. So there probably would be some, especially coastal implications from that, but we'll see what happens there this year. I'll talk about it again maybe in May or June. All right, let's see here. Any thoughts question from David Baker? Any thoughts on what this wet winter and spring would mean for the upcoming fire season? I've touched on this a bit before, but I'll do it again since we're getting closer to erstwhile fire season. I do think that it will greatly inhibit the early portion of the fire season virtually everywhere. So it'll have a late start in a lot of places. And the season may never really get going at high elevations. So we're talking like 9,000 feet. There's just too much snow. I don't think it's going to melt until August. And even when it melts in August, there's still going to be damp ground. So I think what we are unlikely to see are extensive or high intensity, high elevation fires this year. We're much less likely to see fires crossing the Sierra Nevada crest that we've now seen twice in the last 5 years. I think this is probably not a year where that's likely, so that's nice. One less thing to worry about this year. On the flip side, at lower elevations, all of this moisture and this very long growing season is probably going to result in increased growth of grass and brush at low to medium elevations. And so in grassland ecosystems, chaparral ecosystems, oak woodlands, any sort of mixed forest where there's grass and trees intermixed, all of those are probably going to see additional vegetation growth, which will inevitably dry out later this summer, as it pretty much always does. So we could actually see an enhancement of fire season because of the wet conditions during the second half of fire season in those sorts of ecosystems. So overall, I'd expect a bit of a later start. This might be a good spring for some prescribed burning where folks have an opportunity to get it in, especially since the air quality concerns may be less, since it's continued to be a relatively well-ventilated atmosphere for the most part. And then I would expect that there to be a much attenuated fire season at high elevations due to the large snowpack, potentially a slightly increased fire season at lower elevations, again, grasslands, brush, and mixed forest and woodland sort of regimes because of all the extra growth of vegetation. But ultimately, it's going to depend on just how hot the second half of summer is and whether we get early season wind events before we see any autumn rainfall. If we get those multiple warm, dry, hot offshore wind events and or extreme heat waves in late summer and early fall, then we could have quite a serious fire season at lower elevations. If we get lucky and we sort of get an early season rain event like last year, it might kind of decapitate fire season early because it's going to get a late start, and it would be great to have an early finish this year. It would be nice to have a break. So that could happen, but I wouldn't count on it because remember, some of California's terrible fires in recent years have occurred following wet winters. Just think to the Tubbs Fire or the North Bay fires back in autumn 2017, I believe it was. Where the preceding winter was the wettest on record in the same places that then burned catastrophically that October in Santa Rosa, in Mendocino, in Lake counties, and elsewhere. So a wet winter does not guarantee that there will not be destructive fires, but it does change the dynamics of fire season. And in this year in particular, I think that at higher elevations, likely to be an attenuated fire season. At lower elevations, that may not be the case at all, especially if it's hot, dry, and windy in the latter half of fire season. But I also do think we're going to get a late start. I don't think we're going to see any early spring wildfires of any note this year, and we might not even see too much early summer activity. So again, this is one reason why there might be a nice opportunity to get some prescribed burning in, because crews won't be busy so much with other problematic wildfires, at least for another couple months, I would imagine. And the other good news is that's likely true throughout a decent portion of the west. So the lower Colorado Basin has got a great snowpack. It's going to take a while to melt. So that's my current thought about fire season, and I wouldn't expect it to change dramatically. We probably won't have any really new information about that for a couple of months. Might make sense to reevaluate in June, though. Just reviewing the questions further here. A question from Constance about what is the definition of a 100-year storm, and what is the definition of a mega flood? Well, the 100-year storm is actually terminology that a lot of folks in science communication and emergency management don't like to use because it's misleading. Because a common assumption is that it means that it's an event that occurs cyclically on a 100-year cycle. So you get a flood every 100 years. That is not what it means, actually. What it really means is that it's an event that has about a 1% chance of happening in any given year. And there's no physical or statistical reason why you couldn't get it 2 years in a row. It would just be statistically unlikely, but there's no physical reason why that couldn't happen. So what it means is that the likelihood is about 10% in any given year. It means the cumulative likelihood in any given decade of a 100-year event occurring is about 10%, so not negligible over a 10-year period. Over the lifetime of a home mortgage, say 30 years, it's getting close to 1 in 3 cumulative odds of such an event occurring. So it doesn't mean that they recur on any particular schedule. It's not like a periodic oscillation. It just means that on average, such events are estimated to occur about once a century, or about with 1% likelihood in any given year. And so some folks sort of prefer the 1% likelihood definition. Of course, that is problematic for other reasons because statistics are difficult to interpret out of context. So I think I like to talk about cumulative risk over a few decades because most of us are capable of thinking about, okay, well, many of us have lived in the same place for a few decades, or at least the same region. Or if you own a home, you're probably in the same place for a few decades, and so it makes sense to think about cumulative risk over 20 or 30-year time horizons. So in that context, a 100-year event, over 30 years has got about a 30% chance of happening in such a window. What that also means is that seemingly extremely rare events, like a 200-year event, which is often the upper end of flood protection in certain systems, is of course never likely to happen in any given year. It's about a 0.5%, so 0.5% likelihood of occurring in any given year. But of course, over the course of a 10-year period, that's still about a 5% likelihood of occurring, and over a 30-year period, even the 200-year event has about a 15% likelihood of occurring. So again, not negligible. Probably, you can bank on it not happening in that window, but it doesn't mean that it's on any particular cycle. It just means that that's a rough estimate of, on average, how often it occurs. Question, what's the region from Tim? What's the region of the map off of my left shoulder? That's a topographical map of Colorado. I think you can only see part of it right now. So you can see the Rocky Mountain Front Range westward, I think. What you're missing are the start of the Great Plains to the east of Denver. Let's see. A comment from Marty that speaking of storms, I don't hear people referring to the max, I'm assuming precipitation statistics like those for a 25-year recurrence interval 24-hour storm event. Seems like that's pretty relevant in an El Nino period. Yes, there are different ways to talk about recurrence intervals. And so the other thing about, defining the quote-unquote 100-year storm is, are you defining it like how much precipitation falls in a day? Or are you defining it, how much cumulative precipitation falls over a 5-day period or over a month? Those numbers mean quite different things. So there's lots of ways to define it. Everybody has their own pet definition, and often we underestimate the risk because we have a sparse record to estimate from. So that's one problem. There is published literature, though, suggesting that moderate to strong El Nino events are associated with a tilt in the odds towards individual extreme precipitation events, in addition to wet seasons overall. So I know a lot of folks don't like the ENSO precipitation relationships because they're not perfect and they haven't always borne out in recent years, but just every piece of theoretical and model-based evidence screams out that when you have a strong enough El Nino event, that there should still be a relationship between increased precipitation, at least in the southern two-thirds of California, and actually an increased risk of extreme precipitation events across most of the southwestern United States. So folks have asked me after the 2015-16 Super El Nino did not bring widespread heavy precipitation to California and did not end the drought as we had hoped that it would then, would you make the same prediction again if we had another very strong El Nino event? And the answer is yes. I would still, again, even after that predictive failure, if we do get a strong El Nino event in the forecast for this fall and winter, I will make a claim that I would expect the coming winter more likely than not to be wetter than average, with an increased risk of extreme precipitation events. And it's very possible I could be wrong about that, because in any sample size of 1, it's difficult to evaluate probabilistic predictions. But overall, there is just such an intrinsic relationship between strong El Ninos and pretty radical shifts in the atmospheric circulation of the North Pacific Ocean that in aggregate, in the long run, it would be pretty hard for those events to not influence regional climate in California in a way that favored wet events more often than not, with, of course, and obviously, some exceptions. And then another question from Marty about, are the stats changing with the increasing variability of weather? Well, the definition, if we were talking about recurrence intervals for floods, or for extreme precipitation events, or for heat waves, the answer is certainly yes, that the 100-year event, as I like to say, ain't what it used to be. But also, the 100-year event today is different than it's going to be in 20 or 30 years. So these are moving targets. They're shifting goalposts in a lot of ways. And that's a challenge, because we often build our infrastructure. We assess the safety of our infrastructure on the basis of would it withstand an N recurrence interval year event, whether it's a 100-year event, a 200-year event, a 500-year event. But what happens when we build a dam or a levee or something, or a storm drain for a particular event, and then the climate shifts and the 100-year event is now only the 80-year event or only the 50-year event? In fact, there's some evidence that suggests with a couple of degrees of global mean warming, which we're on track to more than experience in the next few decades, that what if that 100-year event actually becomes the 25-year event? What if it becomes 4 times likelier? Those are the kinds of odd shifts that we see after a couple degrees of global average warming. And this is a serious concern for civil engineers and emergency managers and folks who deal with low likelihood but high consequence scenarios. This is a significant concern. And it's getting more and more attention in the civil engineering community, I can tell you that much. So it is a real issue, and we're working on it. Question from David Baker. When's the last time California had 2 above average water years in a row? I don't know off the top of my head, but I feel like 2 substantially above average years, it's been a while to see those in a row. So it would be interesting if we did this year. I don't think it's happened this decade, that's for sure, even though we've had some individual good water years this decade. Mark asks, what atmospheric and/or model variables underpin the spring predictability barrier, which is essentially this notion that the accuracy of ENSO, El Nino Southern Oscillation-related predictions, has a step change towards more accurate outcomes by about late May and June relative to even just a month or 2 before that. It has to do with the background state of the atmosphere and the ocean, and essentially the coupled atmospheric ocean system is very sensitive to subtle shifts in variables because of nonlinearities in the system that occur prior to the spring, and it is somewhat less sensitive to those once the atmospheric configuration in the northern hemisphere summer sets up. That is my understanding of this, essentially, although I'm not necessarily an ENSO expert per se. And essentially what happens is you end up having a system that becomes inherently more predictable after you've breached that spring predictability barrier. So right now, we're in April, we're right in the middle of it, quote unquote, the wrong side of it. On the other hand, there are a lot of other things this year that would suggest that the predictions toward a stronger El Nino are plausible beyond just what models are telling us. So I think that this year, despite the spring predictability barrier, I have higher than average confidence that the predictions from this spring will actually come to fruition. But it is true that in terms of intensity forecasts for El Nino, I wouldn't rely on them too much until we're on the other side of that barrier, say June. A question from Noah about a graphic from our 2018 paper on increasing precipitation volatility in 21st century California, which, by the way, I think is sort of what we're living through now. That's the anecdata that I was talking about supporting predictions. Yeah, I think that's largely still valid. I think that, what warming trajectory we take could be different than the one that we use in that paper, certainly, but the overall picture remains the same. With each increment of warming, it's likely that California will see an increase both in the severity of droughts and also in the severity of extreme precipitation events that could cause floods. So, in other words, an increase in both extremely wet and extremely dry conditions on opposite ends of the spectrum. So, that we still expect that to hold true. I think we're seeing it now. I think we'll see more of it in the near future, but we'll still go through multi-year periods that are more on the dry side or more on the wet side of that. So it'll be interesting to see if this year was the beginning of a multi-year wet period where we could potentially see record-breaking wet conditions because of the fact that climate is now about 1.2 degrees centigrade warmer globally than it used to be, or about 2 degrees warmer globally. The climate is more like 3 or 4 degrees warmer in parts of California and the Pacific offshore. So that's a significant amount of warming relative to the 20th century. And given that the water vapor holding capacity of the atmosphere increases by about 7% per degree centigrade, well, we're above a degree centigrade, so we should be above a 7% increase. You should be getting closer to a 10% increase in that water vapor holding capacity of the atmosphere at this point. That's not negligible. And when a strong El Nino event slings a bunch of atmospheric rivers our way repeatedly, well, you get the cumulative effect of that 7% more water vapor potential in the atmosphere, realizing it over and over and over again. Those are the years where we'd expect to break records potentially. So we did that this year without an El Nino event. It'll be interesting to see what happens next year if we have a strong El Nino, that's for sure. All right, well, I think we're getting close to the end today, so I might wrap up a little bit early. I see my inbox filling up ominously in the background, so I might need to move on to some other things. But thanks again for watching. I really appreciate the continued interest in these live sessions. I think that they are really valuable, certainly for me. I get to reach out to folks who I don't reach through other channels. It's a nice alternative to Twitter in days where Twitter seems to be a slightly less reliable source for some things and a little bit more unstable. So I'm glad that folks know where to find me here. You can, of course, also still find me on the Weather West blog, weatherwest.com. I actually put up a new blog post yesterday. Folks might be interested in reading. It's been a while because of travel and the fact that the weather calmed down, but I did think it was time to put something new out. So there you go. The frequency of these live office hour sessions may decrease a little bit during periods of less active conditions. And as I mentioned before, some of these sessions will focus less on real-time conditions and more on broader topics related to climate change and weather and wildfire and the Earth system more broadly, especially in the American West. But for now, there's still enough going on with the high flood risk from the southern Sierra snowmelt this year, with the developing El Nino, that perhaps we'll always have some topically relevant things to talk about in the short term. So we'll have to mix that long-term discussion in there repeatedly, I guess. So thanks again for watching, and tune in next time where I'm sure we'll be talking more about the rising flood risk in the Central Valley and on the eastern slopes. Until then.